Together, we will be talking about the many threats wildlife is facing and the steps that we can take towards effective conservation. Would you say we are seeing an acceleration of all these threats? And do you think animals can cope with these mounting challenges? Because I think you mentioned this rightly, animals do adapt, but are they going to be able to adapt quickly enough, just like us, really?
We currently have this current biodiversity extinction event, which is largely caused by humans, and it's probably been underway since, for about 12,000 years, when we've started clearing a lot of land for agriculture, and the human population began to increase in size. A few developers would come up to me and say, well, what have you found? And you tell them that you had found a threatened species on the land that they want to develop, or it had potential habitat for threatened species to occur there, even if they hadn't been found. And some of those people would say, well, I want to develop this land. Can't you just move those individuals? The next real big issue is climate change, and it's emerging as one of the most significant problems that we have in terms of biodiversity decline, and it is mostly caused by humans. So there's a lot of climate skeptics who will refute that, but there really is significant evidence to indicate undoubtedly that we're largely responsible for this. The reason I'm so passionate about it is that like everybody else who studies wildlife populations, in our lifetime, we've been able to see significant reductions in populations of animals that we've been studying. We have a moral as well as a legal responsibility to reduce our impact upon all of those ecosystems, because we are part of it. What affects the natural environment also affects us.
Dr. Stephen Ambrose, a very warm welcome to the Shades of Life podcast.
Thank you very much, Ingrid. Thank you for inviting me along today.
Yeah, it's very nice to see you again. So I wanted to check your description on LinkedIn, because I know you, but I wanted to be to the point. So your description on LinkedIn says that you are a science communicator, zoologist, conservation advocate, ornithologist, and recreational bird watcher. Together, we will be talking about the many threats wildlife is facing and the steps that we can take towards effective conservation. But let's start with knowing you better. You live in Sydney, in cold Sydney at the moment, because it's winter for you, it's summer in London. So do I remember correctly that your family is from the UK originally, and what made them make the move to Australia?
Yeah, sure. Great question. I was born in England. In fact, I was born in the city of Liverpool in the north of England, and that was in the 1950s. And my parents decided to take their young family of young children over to Australia in 1969. So I was 10 years old when we arrived here, and my youngest sibling was only 1 year old at the time. Look, it was an incredibly brave thing for my parents to do, to move from one side of the world to the next, to a country that they'd never visited before. But we were just one of many, many English migrants that came out to Australia at that time. And my dad was a carpenter, and of course, when you have lots of migrants coming into a country, you've got to provide housing for them. And so my dad was offered a job before he left England to help with the building of houses using his carpentry skills. And we moved to the western part of the country, to a place called Rockingham, which was which is located just south of Perth. It's about 50 kilometres south of Perth, which is the capital of Western Australia. And that housed a lot of new English migrants. In fact, when we first arrived in the township of Rockingham, which was a lovely seaside town at the time, now it's part of the greater suburban area of Sydney, but of Perth, sorry. But at that time, most of the people living in Rockingham were English migrants, and so we essentially lived in a little England for several years before starting to mingle with the greater population of Australia.
Yeah. Oh, that's amazing. I love stories of migrations. So yeah, I wanted to start with this. So obviously your dad was not working with wildlife at the time, which is interesting as well. So, Stephen, you have over 39 years professional experience as a zoologist, fauna ecologist with a specialist expertise in ornithology, which I didn't know actually before I researched you for this particular interview. Why did you decide to specialize in these areas? And can you take us through the key milestones of your academic background and professional experience?
Yeah, well, it goes back to when I was a young boy in England. I had a teacher when I was a 9-year-old who was extremely good at getting his students, his boys and girls in his class, interested in extracurricular activities. And his name, just by coincidence, was Mr. Heron. And he got me interested in bird watching. And the way he did that was he saw an interesting bird outside the classroom window one day. He asked the people in the class if they knew what bird it was. No one knew. He asked who would like to go to the school library to find a book to help identify that bird. No one volunteered, so he volunteered me, and so I went to the school library straight away. We got a book, and fortunately, when I got back to the classroom, the bird was still there, and with the help of the teacher and the rest of the class, collectively, we were able to identify what the bird was. Unfortunately, I can't remember what the species is, but
Oh, it's such a nice story. Yeah.
Yeah, but that really got me interested in bird watching. I was hooked from that point onwards. And I still don't know to this very day if Mr. Heron knew or recognized an interest in me in that particular subject, or it was just something that happened by chance. So I suspect it was the latter, really. But from that time onwards, I was interested in looking around and finding what bird species were surrounding me and trying to identify them. And a year later, I moved from England to Australia and discovered that the birds here were completely different to the birds in England, and that threw an extra challenge onto me to really find out more about Australian birds, and discovered that at that time in the late 1960s, early 70s, we still didn't know very much about Australian birds, and it provided a challenge for me to generate an interest in finding out more about them and meeting the sort of people who actually do study these birds and true blue bird watchers. And as you said, my dad wasn't interested in wildlife or connected with wildlife, and same with my mum and the rest of my family. I was really the black sheep of the family, but I was very, very lucky to have two parents who really did encourage interests in all of their children. And when those interests developed, they would find, well, they would support them and find people who could help them generate that interest even more. And so my dad started taking me to bird club meetings, and that's how I got to meet other bird watchers. And by that stage, I was beginning to develop an interest in pursuing a career in studying birds. And this is by this time I was about 12 years of age, I suppose. And I remember going up to the president of one bird club, which was terribly named the Royal Australasian Ornithologists Union, or RAAU for short. It's now merged with another bird group, and it's called BirdLife Australia. But that comprised of people who were interested in bird watching, as well as professional ornithologists who were studying birds professionally. And I got to ask this person, how does one become an ornithologist? This was a 12-year-old asking that question. And his response, I mean, he was very encouraging, and his response was, well, really, what you really need to do is to earn a PhD. And as a 12-year-old, I didn't know what a PhD was. And I was too shy to ask him what it meant. And so at the end of the evening, I went back home, and my dad didn't know what a PhD was either. And so the following day, I went to school and asked one of the teachers, how does one get a PhD? And the teacher just looked at me and started laughing in a friendly sort of way and said, well, first of all, you need to finish school, and then you need to go to university and study towards becoming an ornithologist at university. Well, he didn't know precisely how that was done, but he volunteered to do a bit of homework for me and come back with some information. And about 2 weeks later, he did do that. He contacted the universities in Western Australia and received some pamphlets and other things. And it turns out that at that time, and still today, that there are no universities that run a course purely for ornithology. But there are courses for biology and zoology and so on. And what I did find out at that time is that you really do have to enroll in those broader courses, and then you then start to specialize as you go further on in your studies. And so that's what I did. I finished school with the intention of going to university to study zoology and eventually become an ornithologist, and that was a fantastic experience. To graduate as a zoologist stroke ornithologist took around about 8 years, and in that time you realize that birds are a group of species that belong to a wider group of wildlife and or a wider group of animals, and you really do need to study zoology or a biological science to actually fully appreciate and understand how birds fit into the natural world. So it really is important to have that overall understanding of the wider natural world, rather than just knowing about birds. So upon graduating from zoology with a degree or PhD in ornithology, I then went into academia as a lecturer in a couple of different universities. I went to the University of New England, which is in northern New South Wales, on the other side of the continent to Australia, and was there for a couple of years, had a great time up there, before then moving down to Canberra, which is in the southeastern part of Australia, where I worked in the zoology department of the Australian National University. But it became clear to me that it was going to be difficult to stay in academia in the longer term, because Australian universities were beginning to change. We're now talking about the end of the 1980s, and it was actually difficult for young junior people to get long-term positions in universities. And around about the same time, that bird group that I first contacted as a child started advertising jobs that I was interested in, and one of those jobs was to be the coordinator of a national project called the Australian Bird Count Project, which was a national bird census project that involved a couple of thousand people collecting information about bird populations and then bringing all of that information together to actually get a reasonably good idea of what was happening to the status of some of our more common birds. And there are similar projects being run in other countries, particularly the UK and in Europe and North America. And Australia had its own project, the Australian Bird Count, and I ran that for about 5 years. And the RAAU, or the Royal Australasian Ornithologists Union, was beginning to expand in size and increase the number of research projects it was having, and they created a new position, which was someone who's to supervise all of those projects, to be the head of bird conservation and research. And luckily, I was the inaugural person to be given that job, and I stayed in that position for about 4 years and had great fun doing that, before I decided that it was time to widen my horizons and move on to new challenges. And the next new challenge was to move into ecological consultancy, working for companies that advise on more practical issues or more applied issues, and specializing in the ornithological side. And so I ran my own company for about 22 years, after beginning for a short period of time working for a large corporation. I decided to move into a company field myself and work on projects that I was more comfortable with, and providing a level of competence and quality that I was happy with. And that company was run for 20 or 21 years, and the idea was to really assess what impacts particular developments or activities by humans or by people would have on the general ecology of the landscape that they're impacting, and in particular on bird populations. And so you might have heard the expression environmental impact statements or assessments. That's the sort of thing I was involved in, assessing or predicting what impacts would happen if particular developments would go ahead. And if they were approved by the government, then once the development does go ahead, what sort of environmental management was in place, and how effective that management was in protecting wildlife populations, and in particular birds. I've since now retired. I've been retired for just over 2 years, and still extremely active. Involved in a number of different organisations, particularly on their boards, all to do with helping to protect the natural environment. 2 organisations in particular I'm particularly active in is the Royal Zoological Society of New South Wales, and more recently Wild Earth or Oceania, which I know that you've had some involvement with too. But I enjoy being involved in those two organisations because they are heavily involved in promoting animal research and conservation, and not just in my region of Australia, but right throughout the country and throughout parts of the world. And with respect to the latter group, WEO, or Wild Earth Oceania, but they're also very, very much involved in educating people about the natural environment, and that's certainly a big passion of mine, and it's something that we really do need to foster a bit more in today's society.
Yeah, definitely. I always say that. Wow, thank you so much for taking us through your journey. I find it fascinating because I have so much admiration for you and what you do. And I think, it doesn't happen often that you get to know the whole background of someone. And I think that really brings to life the work that you still do today. I also love the fact that, your love for birds came from your childhood. And a lot of people are actually saying that your life purpose usually is shaped in your young teens years. So, perhaps it was not so much by chance. But it's almost like also your heritage from England that you took with you to Australia. That's quite nice as a migration story as well.
Yeah,
Uh, sorry.
yeah. I mean, just one extra point. I mean, it is a big, long story, but you know, I've been extremely fortunate to be in the right place at the right time and meeting the right people at the right time, and that helps a lot. So, in my journey and in my older years now, I actually do like to spend a lot of time mentoring those younger people because I had that experience myself.
Yeah. And to say this to people who are listening now, so we did work on a project together last year, and you made me discover some typical Australian species, and there were two birds, the black cockatoo and the orange-bellied parrot. And the knowledge you have about the wildlife is incredible. So we'll hopefully give a sense of that to people throughout our conversation today. So I know you are passionate and very active about communicating with and involving the general community in science, especially in relation to ecological research and species conservation. Why are you so passionate about that? What is your drive?
Well, how can one not be? I mean, look, if you go out into the natural environment, there are so many wonderful things to see, but also by interacting with all of those passionate people themselves when I was a young person, it rubs off on you very, very quickly. Bird watching in particular is quite a unique interest in that it does tend to attract extremely passionate people. And in fact, bird watchers are probably some of the most passionate people I've ever come across. There are some that are even extremely obsessive about their interest, and I'm not quite in that category, but you know, you do get individual bird watchers who are so obsessive that they travel around the country or around the world trying to record as many different species of birds as they possibly can, and you know, some are even able to when they learn about a new species being nearby them, just dropping what they're doing at the time and just racing off to find them. I remember one particular bird watcher explaining that he was from Sydney. He heard about a species of bird that he hadn't seen in Australia before. In fact, it was a new bird species record for Australia, I think, at the time. He decided to drop what he was doing at the time, catch the first plane over to Western Australia because the bird had been discovered just outside Broome in northwestern Australia, which is around about 1,000 kilometres north of Perth. So he flew from Sydney to Perth and then caught the connecting flight from Perth to Broome. The bird was in a location that was only 20-minute drive from Broome Airport. So he hired a car at the airport to drive down to see the bird, watch the bird for 20 minutes, noted it in his notebook and took photographs of it, then caught the next plane back to Perth from Broome, then from Perth to Sydney. And he did all of that in 24 hours. Those are the sort of people who are very excessive, are able to do those sorts of things. And some might say,
I totally get it, I must say. I'm quite passionate myself, and if you have something you're passionate about, yeah, I could move mountains for sure.
Yeah. But you know, when you start off being passionate about birds, and you move into a university education where you're learning about other wildlife, you then begin to realise that, as I said before, that you can't look at birds in isolation to everything else. And the one thing you do learn as a zoology student is that everything is related to everything else, and you know, a particular species or an individual within a species or a population interacts with other individuals of other species, and what you do to that species or how you affect that species affects the broader environment. And so you do begin to appreciate those ecological processes or those interactions, and it's something that you'd think that we would know a lot more about, but we're still learning a lot about those interactions and what happens when one species increases in abundance or distribution and another decreases in abundance and distribution and so on. And or if you introduce new species to an area, which we'll talk about later. But you know, I guess that passion also is generated by the fact that in my lifetime, I have noticed that as cities grow larger and human populations become larger, we're becoming less connected with the natural environment. There's still a lot of people who are very closely connected with the natural environment, but a lot of people who are in towns, big towns and cities, they have less of an opportunity to go out into the natural world. They're confined to their big towns and cities, and they just don't interact with the natural environment in the way that they should. Yet we're all part of that natural environment, and a good reason why we have so many environmental problems at the moment, I think, is that people are disconnected with that natural environment. And I've come across a lot of people who find that wildlife, particularly wildlife that live in cities, are an inconvenience to them, or in some cases, people are afraid of them. And that's, you know, a real concern to me. And I'm trying to, along with many other people, change that attitude to some degree. And that's really driven my passion in science communication in my retirement years. And also as a consultant ecologist, the other concerning thing that I was finding was that, you know, if you are assessing the importance of a particular area of land or water or ocean that's important for wildlife, and those environments are proposed for development, a few developers would come up to me and say, well, what have you found? And you tell them that you had found a threatened species on the land that they want to develop, or it had potential habitat for threatened species to occur there, even if they hadn't been found. And some of those people would say, well, I want to develop this land. Can't you just move those individuals? And that comes as quite as a shock when you first hear that, but you soon become immune to it when you hear it many, many times. And so you have to sit down with these people and explain that's not how it works, and you can't just do that. And it would be in the longer term better for them to perhaps modify their developments or their activities to minimize or avoid those impacts upon those particular species that need to be protected in a special way. And once you do explain to them what could be done and why they can't have their animals moved, then most of them do understand. But it's just that general ignorance, and that's really part of that disconnection.
Yeah, that really shows a disconnection. Yeah, for sure. It's a great example, actually. Yeah, thank you for that, Stephen. So, as you live in Australia, could you tell us about what makes your continent so unique when it comes to wildlife, if you give us some parameters?
Yeah, it really comes down to two things, and time and geographical isolation. You know, Australia was once part of a huge supercontinent called Gondwana, which formed about 300 million years ago, and Gondwana eventually split up to form the Australian continent and South America and Africa and India, Madagascar, and parts of Arabia. So that big supercontinent of Gondwana formed about 300 million years ago, but around about 180 million years ago, it began to split up, and so Africa and South America split up from the rest of the land masses, and then around about 140 million years ago, Australia began to split up from India or Australia and Antarctica, I should say, split up from India and Madagascar and Arabia. So Australia and Antarctica as one single landmass started moving through plate tectonics southwards away from those other land masses. Then Australia then began to split away from Antarctica, and that began around about 95 million years ago. And that splitting up process between those two continents lasted for about 60 years. So Australia became totally separated from the Antarctic continent about 30 million years ago. But if we look at today's animal species, and in fact many of Australia's plant species, they all began to evolve from ancestral species that originated after Australia separated from other land masses. So that potted history of the movement of continents is important because Australia's wildlife, leading to what we see today, has largely evolved in isolation with everything else. Probably the exception to that are the birds, and I'll come back to the birds in a moment. But yeah. I mean, look at Australia. It's an island continent in a remote part of the Indian and Pacific and Southern Oceans, and it's undergone quite a massive change in its geographical isolation. When it separated from Antarctica, it started moving northwards towards Indonesia or to Asia. And so during that northward movement, you had massive changes in climate. The continent was becoming drier and drier. And when it was part of Gondwana, the landmass that eventually became Australia was largely tropical rainforest or wet forest, and it still was when it was part of Antarctica. But as it moved away from the other Gondwanan land masses, the temperature became cool. The temperature or the climate of Australia became cooler, and we were getting more temperate rainforest rather than tropical rainforest. But as Australia separated from Antarctica and moved northwards, a lot of those rainforest areas died out or transformed into drier woodlands, and eventually some of those woodlands became more arid and desert-like. And so as those environmental changes occur, the animal species that inhabit those environments or habitats have to evolve as well. And some didn't and died out, and others did and evolved and radiated into other species and adapted to the new environments. And on top of that, we've also had some ice ages in Australia. The most recent ice age in Australia ended around about 12,000 years ago. So despite what the environments were like in Australia at that time, all the landscapes, those ice ages blanketed part of the Australian continent, mostly the southern part of Australia. The northern part of Australia and central part of Australia largely escaped those ice ages, but certainly the southern parts of the Australian continent did experience blanketing of ice, and that then sort of transformed the environment even more and caused the extinction of probably quite a lot of Australian species at that time. But so when we talk about, say, marsupials, for instance, and the monotremes, which are the platypus and the echidna, these are all species that evolved when Australia isolated from other land masses. And so that's why it's so important to protect what's on the Australian continent, because most of the species that we find are just not found anywhere else in the world. And so if we lose those species here, then the world has lost those species as well. I mean, if you look at the mammals, the reptiles, the frogs, they all have developed in Australia and Australia alone, and also parts of Papua New Guinea when PNG was attached to the Australian continent to the north as well. So because it's an island continent, those species can't disperse to other parts of the globe, because they don't fly or they don't swim. There might have been a few rodent species from Asia or Indonesia in particular that might have floated across to Australia on logs or other debris that were washed into the sea and have subsequently populated Australia from the north. But by far, nearly all of those mammals and reptiles and amphibians have developed in isolation to everything else. The bird species are a little bit different because they can fly, and birds, some birds have evolved in isolation in Australia to the rest of the world, but it appears that some bird groups might have originated in Australia and have dispersed out of Australia to other parts of the world. And one large group of birds that seems to have done that are the world's songbirds. Songbirds are found right around the world, and it's believed that the Australian songbirds really evolved in Australia or originated in Australia around about 24 million or 50 million years ago, and then around about 24 million years ago they started moving out of Australia to other parts of the world, and they were able to do that as Australia was beginning to move northwards towards Asia. So it's the genetic studies that have been carried out over the last 20 or so years, for instance, suggest that many of the world's songbirds originated in southern eastern Australia. And over time, those eastern Australian birds moved up the east coast of Australia and then into Papua New Guinea, because Papua New Guinea was connected to Australia by a land bridge at that time. And it was whilst those bird species were in Papua New Guinea that they began to evolve into many other different forms of songbirds, because there were lots of valleys and mountains that acted as barriers to the rapid dispersion of those birds. And so those birds produced many different generations that evolved in individual valleys and mountaintops and things like that, until there was an opportunity for them to move further east into Indonesia, and then from Indonesia up into Asia, and then from Asia into Europe, and eventually populating South America, or the Americas. But so you can see that Australia has a special place in the history of wildlife in the world, and as I said, it's really important to remember how important they are, and to protect today's representatives of those species.
Yeah, they are unique, so unique. I was also thinking, there are also probably other migratory species like whales, because they typically go from north to south, south to north. And even if they could be protected in Australia, for example, you can't prevent them from going towards Japan, and it's a bit different there. So it does have an impact also when it comes to conservation.
Yeah, that's right. If we talk about whales, for instance, you usually find that there are two different groups of whales, ones that are found mostly in the northern hemisphere and those that are found mostly in the southern hemisphere. So even though you might have, say, humpback whales in both hemispheres, the two different populations. So the whales that we find in Australia, for instance, or in Australian waters, are mostly species that either live here locally all year round, or species that live in the Antarctic waters and feed in the Antarctic winters during the southern summer months, and then in the winter months they migrate northwards along the east and western coastlines and southern coastlines of Australia to warmer waters and where they breed or give birth to their young calves. Yeah.
Okay, great. So thank you so much for all these explanations about what makes Australia so unique when it comes to wildlife. I also wanted to ask you the question because you are obviously very educated, very aware, very connected with the wildlife you have on your own continent and beyond, as we know. But we know that we tend to live in a human world made by humans for humans, and your example earlier demonstrated that really well. So do you think we consider and connect with the wildlife where we live enough? That's, why you do what you do probably today.
Yeah, well, no, I don't. I think some people do, but as I said before, we're becoming increasingly disconnected with nature, and I do think that there's a real need for more education of young people, particularly about wildlife. I mean, when I was at school here in Australia in the 1970s, I don't think we were taught a lot about biology. I mean, there was a basic biology course that one could enroll in at school, but I mean, that was in the latter years of high school, and you really do need to foster that interest in young people, when they're in primary school or junior school, and the education system here in Australia is beginning to change slowly, and I know that in the last 10 to 15 years in particular, teachers are beginning to run experience classes for young primary school students, where students go out into the local patch of bushland or something like that, and have a good look around at what surrounds them, and record what they see, and the teachers or experts that go out with the teachers explain to the students why those animal and plants are there, and what roles they play, how they're related to each other, and how they interact with each other, and then the students begin to think about what would happen if one of those species disappears or changes in abundance, how that affects everything else that's in the natural environment. And that's great news, but we really do need to work more on that direction. It's happening very slowly, and it's really important that we have that, because then the kids can go back home and tell their parents about what they've learned. So parents learn something about it. But more importantly, I think, is that those young children are the most recent group of environmental managers, and we're training them to care more about the environment, and that we see that with climate change, for instance. You see a lot of teenagers and so on protesting about lack of action over climate change, and that's great. It means that young kids that age are becoming more attuned with the natural environment and how it's affecting them, as well as the broader parts of the planet. And I think that that's a great sign that we have some really good young people being brought up to do the right thing in the future for protecting our planet.
Yeah, as you said, education is so key. I was also asking you the question because when we were working together last year, this is when I discovered a lot of endangered, critically endangered species in Australia. And it was fascinating and I loved it. But obviously, I am not from Australia. I don't live in Australia. And as bizarre as it is, around the same time as we were working on this project, I did a collaboration with quite a well-known artist called S. Devlin, and she does stage installations for usually rock stars across the world. But she evolved her practice more and more towards being more sustainable. And especially last year, she created a project in London where I live, which was about creating an artistic installation around all the endangered species that we have in London. And there were well over 100. I can't remember the exact number. And I was like, wow, perhaps I should look into where I live because there are so many endangered species right here in London as well. And to be honest, I had no idea. And it was so eye-opening to be working on this project with you in Australia. And at the same time, I discovered the endangered species in London where I live. And this is where I see we are all disconnected from the place where we live and the natural world and the wildlife, which needs our support because obviously our human activities impact them. So yeah, that was quite eye-opening for myself as well.
Well, that's a very good point, Ingrid, because the list of threatened species is growing every day, and we'll come to that subject in a moment, I'm sure. But towns and cities actually do provide habitat for many endangered species, and it not many people do know that type of environment, the urban environment, can be important. And here in Australia, for instance, they can city and town environments can provide important refuges for animal species that are escaping bushfires, for instance, or forest fires. So if the natural habitat is destroyed, first of all, the animals have to move out of that habitat and escape the fire. But once the fire is out, they still have to find resources to survive. They've got to find enough food. They may even need to find places to breed and multiply and so on. If those towns and cities don't provide those habitats, then there's nowhere else for them to go. If we can show people that towns and cities and the green spaces within those cities are important for our wildlife, then we help those species to survive those natural disasters like the bushfires, the droughts, the floods, the effects of cyclones and hurricanes and things like that. It's terribly important.
Yeah, definitely. So the next question is related. So we know many species have seen their numbers plummet over the decades. Can you give us some numbers and concrete animal examples of that? Because we know overall figures, but perhaps also to make it more real, let's take a few animal examples.
Look, there's a global group called the International Union for the Conservation of Nature, or IUCN. They produce what's known as a red list of threatened species around the world. In their red list, there are around about 163,000 species. That's not just animals, but plant species as well. So it's a lot of species that are really declining in abundance, and they're not necessarily all endangered, but the declining significantly enough to be a worry that eventually they will become endangered. And of those 163,000 species, there are around about 45,300 of those which are threatened with extinction. and that's awfully worrying. And if you look more closely at what we call vertebrate populations, those animals that have backbones, like the frogs and the fish and the mammals and the birds and the reptiles, about 41% of the world's frog species are now threatened with extinction. About 37% of all sharks and manta rays are all endangered of extinction. 36% of coral species. They're not vertebrates, by the way, but they're certainly amongst a group of animals that are threatened with extinction because of marine heat waves, for instance, and increasing acidity of water. That's putting a great stress on a lot of our coral species, and so 36% of them are now threatened with extinction. 34 conifer species, a group of plants that include pine species, for instance, they're all threatened with extinction. Mammals, 26% of them are all threatened with extinction. And birds are faring a little bit more better. About 12% of all bird species are now threatened with extinction. So we have a massive biodiversity decline, and some of us claim that we're currently in the sixth main biodiversity extinction event in the history of the Earth. We've had some major biodiversity extinction events in the past, largely due to ice ages or volcanic eruptions that have covered the planet. And the most recent global biodiversity extinction event before the current one was when a major asteroid hit the Earth around 66 million years ago and wiped out the dinosaurs and about 80% of other wildlife. And so we currently have this current biodiversity extinction event, which is largely caused by humans, and it's probably been underway since for about 12,000 years, when we've started clearing a lot of land for agriculture, and the human population began to increase in size, so we have this event that we really need to do something about, because we just don't want a massive extinction event to continue, and if it does, then it affects us, because we are part of the natural environment. We're related to all of those species out there in the natural environment and in the urban environment, and what happens to them affects us, and that's something that a lot of people still don't quite understand, and even scientists like myself, we're still learning about those complex interactions, and how the change in abundance and distribution of one species changes everything else around it. But if we look at individual species, and in particular in Australia, there are some species that are so rare that they're in danger of becoming extinct anytime soon, within the next few years. You mentioned one bird species earlier called the orange-bellied parrot. That is a species that really is on the brink of extinction. It's a species of bird that breeds down in Tasmania, south of the mainland of Australia, and in winter it leaves Tasmania and migrates to coastal regions in southeastern mainland Australia, where they spend a lot of those individuals will spend time overwintering in salt marshes, for instance, whereas when they are down in Tasmania, they breed in more closed forest and type of environments. Now, that particular species went down to about 32 individuals a few years ago. It's one of those species that has been impacted by a lot of different things. Habitat clearance is certainly one of them. An interesting threat has been the fact that another species from mainland Australia was introduced into Tasmania, and that species was the squirrel glider, which is one of these small mammals that have flaps on the forelimbs and can glide from one tree to the next. And the scientists in studying that particular, or studying the orange-bellied parrot, began to realize that squirrel gliders were growing in abundance in Tasmania because it had no natural predators. But it was also preying upon the nestlings and the eggs of the orange-bellied parrots in the tree hollows and in the artificial nest boxes that they were nesting in. So there was a very high predation rate, which has certainly impacted upon that species. The orange-bellied parrot, mind you, is one of those parrot species that can be bred in captivity. So the recovery team for that species has been breeding the orange-bellied parrot in captivity on the mainland for quite a few decades, and have released some of those individuals back into the wild. But many of those individuals were released just prior to their migration between the Australian mainland and Tasmania in either direction, and not many of them were surviving. And so what the recovery team has done in recent years is breeding the orange-bellied parrots in captivity in Victoria, in mainland Australia. And when eggs hatch, or when the chicks hatch out, the eggs, when they're about 2 or 3 days old, they're actually air freighted across to Tasmania, and placed in the nests of the orange-bellied parrots down in Tasmania, where they foster, and the parents then foster those young. And it does seem to have helped the survival of the species somewhat. It's still a critically endangered species. It's gone up from about 32 individuals up to about 70 individuals, I think, from the last count. So it's still very much a critically endangered species. It could go extinct any time now, but the fact that the scientists involved in that recovery program have found a way of helping that species in a meaningful way is a good sign and a good direction that they're moving in. Yeah.
Yeah, and it's a beautiful, beautiful bird. And it's like the most critically endangered bird in the world, I think.
Yeah. And I think one of the problems that we have with very, very rare species, particularly those that are in danger of extinction, is that because they're in so few numbers, they're hard to detect in the wild, and so quite often you don't have a good idea of how rare that species is or how close to extinction the species is, because the fewer individuals there are in the wild, you're less likely to come across them. And a good example of that would be another bird species, the regent honeyeater, which is a species that's found in southeastern Australia. When you read the scientific literature that goes back to, say, the turn of the 20th century, there are observations of very large flocks of regent honeyeaters moving past an observer over a space of 15 or 30 minutes. So, in the 1920s, that species was relatively common and quite abundant and probably widespread, but it's now found only in 3 quite distinct separate populations, and its total population size of those 3 populations put together went down probably to close to about 200 individuals. So it's gone from probably thousands or tens of thousands of individuals to a few hundred individuals in the space of 100 years, and that's largely again due to habitat being cleared, but it's one of those species that can be bred quite easily in captivity, and again there's been a captive breeding program, but one of the problems has been that when you've got a small group of birds in captivity, you might not have the whole suite of song that the bird uses to communicate with others within its own species. And so when adult birds produce young in captivity, they're not passing on the full suite of songs to those young birds. And so when you release those young birds into the wild, and because there are so few birds of the same kind or same species that they would encounter, they're not learning the full suite of songs in the wild. And that may potentially be impacting their ability to attract a mate, because they're not using the full suite of songs to attract a mate, or even to find individuals of its own kind to associate with. Since then, the recovery team for that particular species has been playing tape recordings to captive bred birds before they're released, so that they do actually learn the full suite of songs, and so that when they are released into the wild, they're fully equipped with all of the communication skills that they may need to survive and find other individuals of their own kind, and that does seem to have helped the wild population to a certain extent. I think there's probably now around about 300 individuals, so it's increased ever so slightly. So it's one of those things that when you do rewild animals, and particularly animals that have been bred in captivity, it's a long process of recovery. And that's one thing.
Not like, hey, let's do it.
Yeah,
That's amazing. I mean, absolutely. I mean, one wouldn't think of this if you were not telling us. That's amazing. So let's move to threats facing animals, because wildlife faces a broad range of threats, and it would be good for people to understand and consider them, because it relates directly to the well-being and survival of all the other species on this planet outside of humanity. So I would like to spend some time to discuss them with you. To start with, could you simply give us an overview or a short list of the main threats that wildlife is facing in the world today? When we worked together in the past, it was really fascinating because, interestingly, we saw that there are perhaps what we could call common threats that have already been there for a long time, but we've seen there are also new threats that wildlife is now facing too.
Yeah, look, first of all, one should be aware that some species decline in abundance, irrespective of what we do. It's just part of the natural process, and natural extinction does occur. That's happening every day, but certainly the majority of species that we know about that are heading towards extinction, the vast majority of them are largely due to human activities or human influences of the natural environment, and certainly the most significant of those would be habitat loss, and this goes back to the earlier comment that around about 12,000 years ago, humans started clearing a lot of land for agriculture, and that land clearing process has just continued to accelerate as the global human population increases or accelerates as well, and so simply the fact that you're removing the homes of these individuals, it could be an animal species or it could be a plant species, or modifying those habitats in some way that makes it unsuitable for them, certainly makes those animals and plants decline in abundance, and it can fragment populations. So you might not clear all of their habitat. You might clear spaces in between individual habitats, but if animals aren't particularly mobile, they can't move between those particular habitat fragments, and even if they can, moving through open spaces or hostile type of habitats might not be suitable for their survival as well. So that's one particular point. With respect to plants, we mustn't forget that plants do move. People think that they're stationary in the ground, but you know, they share their genetic material over long distances. You know, they produce nectar to attract animal species that can pick up pollen, and those animal species, which could be insects or birds or lizards or even mammals, can transfer that pollen over longer distances, and so and wind can blow seeds to new habitat areas. But if you fragment those habitats, then once again the likelihood of genetic transfer of material between separate plant populations may be reduced significantly. And also plants, most plant species grow in very specific environmental conditions. They like particular soil types, air temperatures, rainfall types, and so on. And if you change those, then you're less likely or you're more likely to reduce the population size of those plants to the degree that eventually they'll reduce their abundance towards extinction. So habitat loss and modification and fragmentation of habitats is certainly a major issue with respect to extinction processes. You might not remove the whole habitat type, but you might remove certain components of it. And one particular component that's particularly important for bird species, and especially birds in Australia, are tree hollows. Here in Australia, trees take a long time to develop hollows. Here, the soils are relatively poor compared with other parts of the world, and which means that they have very low nutrients, and it takes a long time for trees to grow to a size large enough to develop hollows, and so we tend to have trees that grow slowly but live long lives here in Australia, and a hollow-bearing tree might produce a hollow that's large enough for, say, a cockatoo or a parrot or some of the other animal species that use hollows. But it takes about 100 to 120 years for those hollows to develop to the size that can be used by those particular animals. So if you are selectively logging the larger trees, for instance, for wood, those larger trees are likely to have the hollows in them. And so you're removing those hollow-bearing trees, even if you're leaving younger trees behind. So you might have what looks like a complete forest to a novice, but to an ecologist who knows about animal species that use tree hollows, they'll see that there's one critical component that's missing, and that can result in localized extinctions of hollow-bearing species. And similarly, if you totally log an area or totally log a forest with the idea of planting saplings to replace them to grow into taller trees, as I said, those hollows take 100 to 120 years to first develop. So you've got to wait that period of time for those saplings to grow tall enough and old enough to be useful to those animals. And finally, you might keep all of those trees, but remove the undergrowth. And you might do that to help control for the risk of bushfires, for instance, because bushfires can start among the undergrowth and then create a lot of fuel to produce a massive fire that then goes up into the tree canopies. So one common bushfire risk reduction measure is to remove that undergrowth. But if you have canopy dwelling birds or birds that use or animals that use tree hollows, you might find that their main food source is within that undergrowth. So you might find, say, another critically endangered species called the swift parrot, which is a major topic of issue here in Australia at the moment. It's a species that's rapidly declining, and it is likely to become extinct in the next few years if we don't do something meaningful to stop that from happening. And what's happening in the forests down in Tasmania, where this particular species breeds, is that the hollow-bearing trees that they use for breeding might be kept intact, but the undergrowth is being removed, and they rely upon the nectar from some of those shrubs and bushes and the seeds to feed upon. But if that's removed, you're effectively starving them, and they die. And that seems to have been what's happening to some extent with that particular parrot species, not just in Tasmania, but in southeastern mainland Australia, where it migrates.
Yeah, we are seeing all the connections happening as you describe them. And we did work, I mean, I've actually learned from you about the importance of the hollows in trees for bird species last year, and I didn't know about it. And now every time I see a tree with a hollow, I actually notice it. But yeah, that's the type of thing we need to consider. So let's continue on doing a list of threats, and perhaps we combine and we give an example of animal every time. So you talked about habitat loss, about the hollows in trees. What else would there be?
Yeah, sure. Well, drainage of wetlands is also a big issue. Again, here in Australia, it's a major issue because we are a dry continent. We also are a continent that relies a lot on agriculture, and of course we plant crops that are very thirsty plant species, and so we need to irrigate those crops, and so we have a region in inland southeastern Australia, for instance, inland of the Great Dividing Range, called the Murray-Darling Basin, which is really the congruence of two major river systems and the tributaries, the Darling River that flows from from southwest Queensland into New South Wales, and we have the Murray River, which essentially drains water from the river systems on the inland side of the Great Dividing Range and flows through New South Wales and into South Australia, and then eventually flows out to the coast in South Australia. But we have quite a significant cyclone season in northern Australia each summer, and those cyclones, when they go through their normal patterns, deposit a lot of rain in northern Australia, and a lot of that rain then can make itself into the Darling River and flow southwards into the Murray River. And the Murray River is essentially a river in semi-arid environments, and so it fills up from water that's much further to the north, and flows through that semi-arid environment, and that allows the huge amounts of water that flows along that river and from the mountains of the Great Dividing Range each year in a normal rainfall season can be quite voluminous, which suits for the growing of agriculture. But and so much so that some of the thirsty crops that we plant are things like cotton. You couldn't really find a more thirsty crop than cotton, except for rice, because we also plant rice in some parts of that river system, some parts of that river system as well. And that's because the farmers can divert water from that Murray-Darling River system onto their fields and irrigate those thirsty crops, and that takes the water out of the natural riparian environment or riverine environment. Now, those rivers eventually flow into major wetlands, but if you're removing that water from the river systems to irrigate your crops, less and less of that water reaches those wetlands. Yet those wetlands are some of the most important wetlands in the whole continent for water birds and for other species like frog species and so on. What you usually find is that in high rainfall years, so much water naturally would flow into those wetlands that you would have a huge burst of breeding from water bird populations. And whereas in dry years, when there's very little rainfall, those water bird populations wouldn't breed as much. And so they're relying on those really good rainfall years to sustain themselves over the long term from a population point of view. But as soon as you start removing that water from the rivers to irrigate your farmlands, less of that water flows into those wetlands. And so those boom years become fewer and fewer because the wetlands aren't really filling up as much. And everybody realizes that problem: the farmers, the government, the scientists, the general public are beginning to become more aware of that. And the government is starting to buy back more water from the farmers, and farmers are beginning to grow more dryland tolerant crops. But we still have a long way to go, and the amount of water that's being returned back to those river systems from those farmland areas is still by far not enough to return the cycle back to normal.
Yeah, I mean, we can really clearly see how important water management, the management of our water resources are, and also all of the connections again, because obviously you're explaining the impact on wildlife, but I have a fashion background too. And you rightly mentioned cotton, because we know it's a very thirsty plant. And I don't think people realize, when they wear a cotton t-shirt, which is a great material because it's natural, it's biodegradable. But then the dark side of it is that it's very thirsty for water. And so it does, our choices, even for what we wear, do impact then wildlife, as we can see through this example. So that's important to know, because if there is a demand for example, more garments made out of cotton, then we will continue to need more water for sure. And then it's not going to help solve these issues. So it's creating, connecting the dots to understand all the chain of consequences in a way, so that we can make more informed choices at every level, including, as an end consumer, obviously. Okay, that's great. Stephen, what else would you like to bring up?
Oh, well, let's move to the marine environment, and one of the things that is a global problem is that we are overfishing, and from a commercial point of view. Once again, we depend very much on the ocean for food as a species, and the larger the global population of people grows, the more we demand food from the ocean, and commercial fisheries are increasing the load of fish that they're taking from the ocean, and they're developing more efficient ways of harvesting fish from the ocean and other marine life. And you know, you've probably heard about these industrial size ships or fishing ships that move around the world's oceans, and they trawl the oceans with huge nets, which are indiscriminatory, and they scrape along the seabed and just bring everything up with them. So that's not only impacting individual species, but whole marine ecosystems. And I guess the other aspect of the marine environment too is that we're beginning to see the effects of climate change, and we'll talk about climate change in a little while in greater detail. But you know, as we emit more greenhouse gases into the atmosphere, the warmer the atmosphere becomes, and that then warms up the ocean. The ocean absorbs carbon dioxide and becomes more acidic. And when the oceans warm, the currents change, ocean currents change, and fish populations and other mobile marine species are dependent upon those currents. And so when there's a change in those currents, then you change the distribution and potentially the abundance of individual species within that marine environment. And when you move species from one part of the ocean to the next, they come into contact with new marine ecosystems, new species, and that can potentially create conflict between the existing species in those cooler parts of the ocean with those warm water species that have moved into those cooler parts. And that's an area that we're still not yet fully in tune with. I mean, it's something we're only beginning to understand at the most basic levels, because we're only beginning to notice it. But it's likely to be
like, sorry to interrupt you, it's almost the same as with humans when we see migrations and people move to another country and it creates conflict. It's like the same in the ocean, isn't it?
Yeah, that's right. Yeah, and because, you know, in the case of the marine environment, you might have new predators moving into a new marine ecological community and start impacting upon species within that community. They might bring in new diseases, for instance. They might be competitors for the same food sources and so on. So, you know, it really is quite a complex thing, and we're really just scraping the surface at the moment in terms of our understanding of those particular impacts. You know, another impact that's become more and more obvious in terms of those changes in the distributions of fish populations, and as well as the reduced abundance, is that one group of animals that is certainly being impacted outside the marine environment are seabird populations, because seabirds are restricted to where they can breed. That, you know, they usually breed on islands or in coastal situations such as cliff faces and so on, and they can only afford to find food for their nestlings in a local area around the breeding colony. They can't afford to move longer distances away because they're spending too much time away from the nest otherwise. So but if the ocean currents are moving those fish populations elsewhere, out of the range of the seabirds, then those seabirds don't find enough food, and certainly not enough food to raise chicks successfully. So in the last few years, we've begun to notice that some seabird rookeries are beginning to not have as high a success rate in terms of producing new chicks, and so the populations are beginning to decrease in size, and that's because hungrier birds are not surviving, and either at the adults end of it or at the first signs of life when chicks hatch out from eggs. And so it really is a major problem. And some of those seabirds, when they do finish their migration, finish their breeding, do migrate long distances. And if shearwaters, for instance, migrate from Alaska to or the Alaskan waters off the coast of North America and down to southeastern Australia each year. So they breed in the Northern Hemisphere and then they avoid the cold Northern Hemisphere winter by then migrating down to Australia for the summer period where there's plenty of food. But if you've not got enough fat on your body to make that migration, then that migration might be disrupted. Some of those birds might not be able to finish their migration at all. What we're also finding is that large numbers of these birds are actually taking much longer to reach Australia from their breeding grounds, and that's probably because they've got lack of body fat, and they've got to stop somewhere and land on the ocean surface and feed a bit more, and then carry on again. Whereas previously they might have all done it in just one flight. That's a major. It's an emerging problem and an immense growing concern, really. So that's largely as a result of changing currents from climate change, but also from over harvesting of the fish within local waters and so on. So there's a huge conflict or competition between those bird populations and we as people who feed on these fish, or harvest those fish.
Yeah, I actually did follow some conservation projects about birds migrating from Russia to Europe or the UK. And there was all these threats that they face on their migratory journey, which is really interesting because we don't consider, there are birds migrating in the sky, and what we do on the ground, there are so many threats they face, and we just don't even think about it. Yeah. Okay, that's great, Stephen. I mean, we could talk about marine life forever. What else?
Oh, look, another major issue, particularly here in Australia, is the introduction of invasive animals. It's probably behind habitat loss. Invasive animals are probably the most significant cause of decline of Australian animals, particularly small to medium-sized mammals. When Australia was first colonized by Europeans, particularly the British, 230 odd years ago, we also brought with us some of the invasive animals that we either deliberately or accidentally released into the natural environment. Some of the deliberately released animals would have included things like foxes and cats and rabbits, because they were part of the British environment, and our early colonists wanted to transform Australia into something that was more English looking and feeling, I suppose, and so those animals were deliberately released into the environment, and some took a long time to establish large populations, and some spread very, very, very quickly and increased in abundance very quickly, and of course tremendous amount of damage to the Australian environment. We also have animals that were probably released accidentally, such as rats and mice, and they too have created havoc to the Australian environment. So foxes and cats, they are apex predators, and they found a ready food supply in Australia once they started spreading across the continent, because Australian wildlife largely evolved in the absence, well, did evolve in the absence of those predators, and so they hadn't learned strategies to avoid predation, and they were taken by surprise. And you know, if you look at the impacts of cats and foxes alone, they're probably responsible for the extinction of about 39 mammal species alone in Australia, and because they've just eaten them all out. Whereas
Yeah, I know it's a massive problem for you, and I was really surprised to see to what point. And I know many people in Australia are working on it and coming up with solutions and monitoring. But yeah, it's really massive where you live.
yeah, it is. And I mean, cats and foxes in particular have been able to colonize pretty much every terrestrial environment in Australia. And you know, you can be traveling through central Australia, which is the driest part of the continent, and see a fox or a cat in the distance, and they might not be looking so healthy looking, but in that marginal environment, but they're still surviving, and they're still causing you know, a lot of damage to the natural.
Yeah, definitely. No, that's great that you brought that one up, because yeah, I wasn't really aware of the issue before I worked on wildlife projects with Australia. So yeah, that's quite eye-opening as well.
And probably one of the biggest villains of all is besides those two are rabbits, because you know, they breed very rapidly, and they have voracious appetites, and there was a lot of food for them out there in the natural environment, and so when you've got millions and millions of these rabbits invading or gradually spreading throughout the continent, and breeding up into even larger numbers, all very hungry ones, then they can really eat out the environment, and you know, they're herbivorous animals, and can really change the structure and quality of habitats just by sheer numbers of them eating lots and lots of plant material. And that too has contributed very significantly to the decline in a lot of mammal species. You know, one thing that we forget is that most of Australia is largely a dry continent, and of desert or semi-desert environments, and the soils are very poor in nutrients in most of those locations. Yet Australian plants have evolved to survive in those low nutrient soils by taking out what nutrients are in those soils and storing those nutrients in their plant tissues. So when an animal eats plant material, they're getting a reasonably good dose of nutrients because those nutrients are in the plant material that they're eating. So if you remove most of that plant material, you're impacting upon those animal species by a great extent by removing most of the nutrients that they rely upon for survival. So another group of animals that we've introduced to the Australian landscape are livestock, you know, cattle and sheep in particular, and in those drier, more arid regions or semi-arid regions, they range over large areas, and so you know, those livestock eventually are then harvested for human use, either for consumption or for leather or wool or whatever. But you're removing those animals out of the environment, and they've consumed all of those nutrients that are in the plant material. So by removing them from the environment and taking them to abattoirs or whatever, you're removing those nutrients from the environment for good. Whereas those animals that live there naturally, the native animals, they might eat the vegetation material, but they die within that natural environment and their bodies decay, and those nutrients are then returned back into the soils. And then the cycle starts again, the plant's able to pick up those nutrients. So there's a recycling of nutrients in the environment, which doesn't occur when you take animals out of the environment, such as the livestock that you're harvesting.
Yeah, okay, yeah, that's eye-opening as well. So should we talk about two more threats? Should we talk perhaps of illegal poaching, illegal trade, and then finish on climate? Because I definitely want to talk about climate.
Yeah. Look, I mean, illegal poaching is certainly an issue here in Australia and in other parts of the world. It's probably not such a big threat as the others I've already mentioned, but still of concern. I mean, if you go to places like Hong Kong and Singapore, for instance, and visit some of the street markets, you'll see all sorts of Australian animals for sale that are being housed in cages, and they can be reptiles, they can be frogs, they can be birds, they can be small mammals, and they've obviously been poached from the natural environment here in Australia and smuggled through international travel to those overseas destinations. I think it's one of those issues that is a growing problem here in Australia, but we are beginning to develop techniques for detecting those smuggling operations, which are becoming much more efficient these days. And I think perhaps illegal poaching and smuggling may be more of a bigger issue than in other parts of the world than in Australia, but it's certainly something that we need to keep an eye on. But as you say, the next real big issue is climate change, and that's a pet subject of mine. I spend a lot of time talking about that, particularly on social media, and because it is a huge problem, it's emerging as one of the most significant problems that we have in terms of biodiversity decline, and it is mostly caused by humans. So there's a lot of climate skeptics who will refute that, but there really is significant evidence to indicate undoubtedly that we're largely responsible for that. And I've talked about marine heat waves, and here in Australia we have a number of major tropical reef systems, as there are around the world, that are being subjected to those marine heat waves. And the Great Barrier Reef, for instance, has experienced 7 major heat waves. I think we're on our 8th one about to experience later this year. And the first main heat wave really wasn't recorded until the late 1990s. And so it's a relatively new phenomenon. And when a marine heat wave hits a reef, it can cause coral bleaching, and in the best case scenario, a proportion of the coral reef will become unwell and lose its coloration and just go white. And over time will recover as the marine heat wave subsides and disappears, and you have the cooler water coming back in again. But it takes time for the coral to recover from those marine heat waves, and we're now beginning to experience marine heat waves at a rate now that doesn't allow the coral to fully recover in some parts of the reef. And so one might expect, or the marine scientists all tell me that within our generation we could lose the reef altogether. We have a number of other reefs that are in similar conditions. We have the Ningaloo Reef off the coast of Western Australia, northwestern Australia, and we have a cooler water reef, a temperate reef called the Great Southern Reef, which is off the south coast of Australia, which is also beginning to experience the same sorts of things as well. So that's an obvious thing that climate change can tell you what is happening, and there are other things that are less obvious, but are certainly having a significant impact upon our natural environment and our wildlife populations. And certainly, the reason I'm so passionate about it is that, like everybody else who studies wildlife populations in our lifetime, we've been able to see significant reductions in populations of animals that we've been studying. And a lot of those impacts I've already talked about are impacting upon those populations that we're observing. But climate change is also one of them too, and you know, it's changing the distribution or reducing the distribution of particular animals, or causing diseases to occur. You know, one disease that's hit frog populations worldwide, which seems to have been influenced by climate change, is a particular fungus that attacks the skin of frog populations. That's called chytrid fungus. It's a fungus that actually feeds on the keratin of the skin of frogs. The keratin is a substance or a protein that holds the skin together. But if the keratin starts breaking down, you then start to get lesions in the skin of the frog, and that then allows bacteria and other pathogens to enter the body of the frog. And it also makes the skin less able to exchange oxygen and water between the inside of the animal and its external environment. And certainly the warming of waters that the frogs live in has contributed significantly to the growth of that fungus, and as a consequence has attacked more and more frog populations. And we as people have actually helped spread that fungus too, because if we walk through wetlands and pick up the fungus on our feet or on our hands and move to another wetland, or if in case of a biologist, if you're handling a frog species without the proper precautions, then you could literally transfer that fungus from one individual, from one wetland to the next, and that helps in the spread. And it seems that widespread movement of the fungus in the 1970s through to the early 1990s globally. And we don't really know where the fungus originated, maybe Africa, maybe South America. It's one of those two continents, but because people were moving or dispersing between continents, and because the climate was beginning to change to favor the growth of that fungus, we've really created significantly to the demise of a lot of frogs, and quite a few frog species have actually literally become extinct as a result of that fungus.
Yeah, definitely. I mean, I love that you bring up this example with the frogs, because we all have in mind, you know, iconic pictures of bears dying, because obviously there are all these problems in the Arctic. And I think we link it really easily to climate change, but there are animals all over the world who are suffering from these climate changes, and you gave some examples. I think it's good to be aware of that, because it impacts the whole animal world as a new threat, obviously humans too, but let's not forget the other species. So let's move to coping mechanisms. Stephen, because you did mention this earlier, that species are known to evolve over time, and some species are also very good at adapting to changing circumstances. I have a fox in mind, because I remember a documentary where I've seen how adaptive they are, and obviously we adapted to Australia as well. Would you say we are seeing an acceleration of all these threats? And do you think animals can cope with these mounting challenges? Because I think you mentioned this rightly, you know, animals do adapt, but are they going to be able to adapt quickly enough, just like us, really?
Yeah, look, it depends on the species and the types of groups of species that we're talking about. I mean, if for instance, you're an animal that has a very restricted distribution, not very mobile, and affected by what's happening in your local environment entirely, then you're less likely to survive changes in your environment because you can't move away from those threats. And again, a lot of to use the coral reef example, that there are a lot of what are known as sessile animal species that live within a coral reef system. They're what sessile species means, that the sedentary animals, and so the conditions of the water that they live in determines on whether or not those individuals in that water survive. So if there's a massive change in that environment, or as a result of, say, climate change, or the introduction of a new species that's invaded that coral reef, then the likelihood of those species adapting and surviving over the long term is not as good as a species that is able to avoid those things by moving to another location. And some species might be good at surviving particular changes, but is genetically programmed to live under specific conditions. So if they move over longer distances to avoid conditions, the genetic programming, the characteristics they've inherited might not allow them to survive those new conditions. So it really does depend on species, and also your reproductive rate is also important. So if you're a species that has a very short lifespan, but a very productive reproduction, producing lots of new generations, then the chances of evolution occurring is to cope with those individual changes is much greater than, say, when you're a long-lived animal like a whale, which only produces one calf a year at the most, and can't readily produce new generations that evolve with the changing times.
Yeah, definitely. So for the next question, I really wanted to have your input as an expert. So every year we are losing species, and there are these discussions, or there is this questioning that I hear often around some species being keystone species. And if we lose them, it would have the power to have a dramatic impact on the whole ecosystem. So would you agree these keystone species exist? And could you perhaps give us an example of one?
Yeah, sure. I mean, every species really is a keystone species, but there are, I guess, there are specific species that are more keystone species than others. Keystone species essentially means that if their abundance changes somewhat, or if they disappear altogether, they're going to have a significant impact upon the entire ecosystem that they're part of. So a good example would be right at the very bottom of the food chain or food web would be things like marine algae in the or phytoplankton in the ocean systems. They absorb oxygen from the atmosphere because when they're floating on the surface of the water. Sorry, they absorb carbon dioxide, I should say, when they're floating on the surface of the water, and convert that through photosynthesis into oxygen. And that oxygen is released into the water, and it helps to oxygenate the water. They also photosynthesize compounds within their bodies to produce nutrients that can be used by other species that are higher up the food chain. So you might have individual crustaceans, for instance, that might feed on the phytoplankton, or you might have large species like whales feeding on those small crustaceans like krill, who've been feeding on the phytoplankton. So if you so everything that's higher up in the food chain is dependent upon the abundance of those very small microorganisms in the water, because without those microorganisms, you're not going to get individual species or organisms higher up in the food chain getting the nutrients that they require to survive. So if you remove the phytoplankton, you're not going to have an ecosystem at all, and that makes them a keystone species. But at the other end of the food web, right at the very top, you might have apex predators, and a keystone species that has created a lot of attention in the last few years in the Northern Hemisphere, for instance, particularly in Europe and North America, is the wolf. Where there's been some rewilding programs where they've reintroduced wolves into the natural environment, and they prey upon herbivorous animals like goats and things like that, and other medium-sized mammals. Now those herbivores, by their very nature and name, feed on vegetation, and so if there were too many herbivores, they eat all the vegetation, and they create an eroded landscape, and that again creates a collapse in the ecosystem that they're part of. But if you introduce wolves back into the environment that prey upon those individual mammals or herbivores, they keep the numbers down to a level that's now sustainable, and so it keeps the ecosystem going and remains relatively healthy. So that's a good example of a keystone species right at the top of the ecosystem.
Yeah. And I love you took an example from the ocean and an example from land. That's great. Thank you for that, Stephen. So my next question, I titled it, when it's too late, or is it? So in Australia, you have lost already some very iconic species, and I have in mind the Tasmanian tiger because it is so iconic. There are programs in place to try and revive them. And for example, there are other programs looking at resurrecting the northern white rhino is another really famous example, because sadly their population has shrunk totally. So could you tell us about that? And according to you, what are our chances to revive some species that perhaps we have lost, or they are down to 1-2 animals, and can we do something about it?
Yeah, look, that's a very controversial subject, and there are supporters for that, and there are those that are widely against it. I'm in that latter group in many ways. The idea is that the theory behind it is that if you can isolate fragments of DNA from extinct species, or even whole genomes of extinct species, you can then use those DNA fragments or replicate them in some way, and place them within either stem cells or unfertilized eggs of donor animals, or donor species, or surrogate species. And you mentioned the white rhino as an example of an extinct species, and the black rhino can be potentially a surrogate species to do that. Other species that have that process thought through things like bringing back the woolly mammoth through trying to use the African elephant as a surrogate species. Here in Australia, we have the Tasmanian tiger, who's the last known individual, died in captivity in 1936, and scientists have been able to isolate fragments of DNA from that. And so there's the research group here in Australia that's busily trying to find a way of using DNA or replicates of that DNA to feed into the DNA of existing closely related species to recreate and you know, the thylacine again, or the Tasmanian tiger. But first of all, when you do that, you're adding DNA from an extinct species into the DNA of an existing one, and so you're not going to create a pure breed of extinct species. You're creating a hybrid of some sort. So you're not going to bring an extinct species back in totality. You're going to have a hybrid. Secondly, there are logistical problems. You know, if you're going to use unfertilized eggs or stem cells to create an embryo of some sort, or an early embryo, that embryo then has to be implanted into an animal, and ultimately a different species, the surrogate species. Now that creates a problem in itself, because you know, a pregnant animal, if it's got a foreign body inside it, that triggers the immune system, and if it's not recognized by the animal as part of its own species complex. So if you've got a foreign species growing inside you, albeit a hybrid or something that's close to the extinct species, then the animal's immune system is going to attack that, and the embryo is probably not going to survive. So if that technique is to develop further, one has to develop a way of overcoming that natural immune system, or growing the embryo outside a surrogate animal. And secondly, in using surrogate animals, you've really got to use an animal that's pretty much the same size as the extinct animal, and that might be possible with the two rhino species, because you know, they are quite very closely related and same size, and probably have very similar immune systems. But when you're talking about the thylacine, the closest really living relatives of the thylacine are things like numbats.
Yes, I was scared of numbats, yeah.
Are really small. The thylacine is around about the size of a...
It's like numbats are really small to tell people, and the thylacine is like a dog.
Yeah, that's right. It's about the size of a medium-sized dog.
It's a squirrel and a dog, basically.
Yeah, numbat is probably a little bit larger than say a squirrel for those people in the Northern Hemisphere. So you know, and they really do have quite different ecologies, so there's no way that you're going to get a surrogate animal for the thylacine. So from that perspective, it's probably a fairy tale that we're going to have thylacine roaming the natural environment again. But you know, apart from all of that, the environment has changed so much since the extinction of the thylacine. You know, thylacines also used to roam mainland Australia, and they became extinct several thousand years ago, and the last ice age may have contributed to their extinction. Some people think that the movement of the dingo into Australia 4,000 to 6,000 years ago may have also contributed to the extinction of thylacines on the mainland. But because the dingo is not present in Tasmania, it survived through until 1936, until it was hunted out to extinction, but by humans. But even so, in the time of either the Tasmanian extinction or the mainland extinction, the environment has changed, the species composition has changed, abundances of species have changed, and so if we did have a thylacine hybrid to rewild, would it survive, and how would it fit into that modified environment? One silver lining to all of this genetic work, though, is that the scientists involved in that are developing new gene editing techniques, and which might come in handy in other types of conservation work, and perhaps modifying the gene of an animal that is declining rapidly in abundance and may become extinct fairly early on. And so if we can perhaps modify genes or to say make them less susceptible to diseases, for instance, then that might help reverse the extinction or the vulnerability to some threats like diseases and so on like that. So scientists are learning through this rather fairy tale exercise of new techniques of helping animals, but you know, the promoted ideas, I think, are pretty much at this point in time.
Yeah, and usually the media really love them. But there is actually a question I didn't ask you earlier, but I think it links nicely to this, because I wanted to ask you, you know, is it as easy as repopulating, you know, when we've lost so much of the animal populations? And one of the issues for me is that, you know, it's like something we've seen with the tree planting movement, for example. You know, people have been planting trees left and right. And in some places, they have seen that they have planted all these trees and the trees are just dying because the conditions are not there anymore, or it's not the right trees for the place. And it's just not as easy as, oh, let's plant these trees and then problem solved, or let's repopulate wildlife populations and it's problem solved. If the conditions, you know, habitat loss, I think I loved your example earlier about the range of songs of the birds, because it has so much impact also on their evolution, their survival. There is a lot more to consider, and we also need to look at the root causes of what has provoked these issues for wildlife in the first place. And if us as humans are not able to solve them, perhaps it's not as easy as repopulating, right?
Yeah, look, a good illustration of those sorts of difficulties would come with some of the rewilding programs here in Australia. We seem to be quite successful now in breeding some threatened species in captivity, and I've mentioned some of the bird species earlier, but it's also happening too with frog populations and mammal populations. So a lot of desert mammals, for instance, that have become extinct either in the wild or close to extinction, or have been locally extinct in some areas of the continent, are now being rewilded. But you know, the major threat to them in the first place that led to their decline in the wild were those invasive species I talked about, and so now these rewilding programs, reintroducing captive animals back into the natural environment, such as those desert environments, are now being put into fenced reserves that are protected from those invasive species. So first of all, the conservation groups that have been involved in that, and they're doing great work, I might say, in rewilding those populations. They first of all had to fence those areas, and some of those areas are quite large. I mean, they might be tens of square kilometres or even hundreds of square kilometres in more extreme cases. And they have to remove the invasive animals, or the predators that are within that fenced area to begin with. And once they're satisfied that they've removed the foxes, the cats, the goats, the rabbits, anything else that might be competing or preying upon the animal species, they then can release those captive bred animals into those enclosed reserves. And that's been very successful in many cases, and populations of those captive bred animals have started breeding in those reserves and have bred up. And but you know, the question is, what happens next? You know, do you then release some of those captive bred animals back into the unfenced areas where those competitive animals are there, and or do you allow them to, or do you still confine them to those fenced areas until you're confident that you can get rid of those invasive animals from the continent? So in one way, they can be seen as an insurance population for when those invasive animals have been eradicated. But are we going to totally eradicate those animals? And that's the other big question. And the other problem is if you maintain the population only within the fenced areas and they keep on breeding, eventually you're going to have overpopulation of those animal populations, and that's when you start having problems with starvation and diseases and so on. So what do you do then? Do you then start culling some of those released animals in order to reduce those other threats that emerge? It's something that we haven't yet, a situation we haven't yet reached, but
such a cycle, you know, once we've disturbed the natural environment and everything was working in a natural cycle really well, then you know, you can find solutions, but then there are new threats appearing as well. And it's like a new cycle of threats and solutions. I don't know.
Yeah. Well, look, there's some fantastic work or research that's underway at the moment to try and solve that problem. And that involves actually training those captive bred animals either before they're released or after they're released to become more predator savvy. So you know, there's all sorts of experiments where these rewilded animals or captive animals are subjected to either predator lookalikes or those predators in other compartments within the reserve to train them or to educate them that these are nasty things that you should keep away from. So so these rookie animals, these student animals are being educated to look out for those introduced predators and to develop anti-predator behaviors. So if that's a relatively successful program in the longer term, then that might be an avenue for them to release some of those reserve populations into the wider community or wider environment where there are those predators. And it's an exciting program of research that's underway, but we're yet to see how successful it will be.
Yeah, that's great, Stephen. Thank you for these insights. So the next question is because I always try to keep in mind the urgency, you know, of the crisis we are facing, climate change, biodiversity loss, etc. Would you say that the threats we are seeing are global at a similar level, or are there places on Earth where you would say things are worse? And for reasons X, Y, Z, should we pay more attention to certain parts of the world and their wildlife because somehow they are key in the big picture? I was wondering.
Oh, yeah, that's a difficult set of questions. And look, the point is that it is a global problem, and no matter where you are on the planet, there are some major biodiversity problems. This goes back to the comment I made earlier that we are undergoing a sixth mass extinction event of biodiversity planet-wide. And but yeah, look, there are some areas that are more vulnerable than others, and if you look at areas where there are the highest biodiversity, they are usually in forest environments, and it's those forest environments that are disappearing very quickly. They're being cleared and harvested, and or being transformed into agricultural land, or in some cases urban land. But you know, there are some forested areas that are particularly more important than others, in my opinion, in terms of planetary processes. And we always pay attention to what's happening in the Amazon, for instance, and the terrible stories we hear and see about the amount of rainforest that's being cleared. But we know that that was once such a large area of land or such a large area of forest that it was controlling global climate, and its clearing is now beginning to change the global climate, particularly in that part of the planet. That's a worrying thing. So not only are we losing biodiversity from that forested area, we're actually potentially changing climate processes that affect biodiversity in other parts of the planet, and that's a very worrying process. Tropical forests in other continents too are really disappearing at quite an alarming rate. Here on my back doorstep, we have a lot of tropical forests being cleared in places like Indonesia and Southeast Asia, and being replaced with palm plantations and palm oil plantations. That's destroying the habitat of a lot of tropical species and animals and plants, and who knows what overall impact that is having, because no one is really able to grasp at such a large scale how ecosystems are disappearing and changing altogether. But even in more temperate regions of the world, such as in Northern Europe and North America and places like that, we're getting disappearing boreal forests, and we're getting changes in the Arctic regions. So you're getting more woody plants migrating northwards as the Arctic begins to warm up and ice melts, and so you're getting reduced Arctic tundra areas, because which are the sort of the shrubby grassland areas that are ice free, because those woody plants are now spreading into those areas and creating a completely different ecosystem. So my message is that yes, there are some more problematic areas, but the whole planet is in trouble at the moment. It sounds very depressing to say that, but it really is, and we have a moral as well as a legal responsibility to reduce our impact upon all of those ecosystems, because we are part of it. And as I mentioned near the beginning of this interview, what affects the natural environment also affects us.
Yeah, absolutely. Absolutely. I mean, I totally agree with you. I mean, it's not even about agreeing or disagreeing, obviously. I also ask you the question because I also really want people to understand that, well, one, we do need to look after our environment where we are. I think that's so key. But also what happens somewhere else will impact us as well. So I think it's also important to understand. And as you said, the efforts need to be done everywhere. So what would be good steps for people to take? Is it getting to know your local environments and wildlife and taking steps to help them make them thrive, for example? What would you say is the most important for people?
Yeah, look, there's lots of things that people can do, and first of all, we can make our governments know that we are concerned as global citizens, or even as local citizens, that the environment is in trouble and we need to do something about it, and that biodiversity is on the decline. If you harass your local MP, member of parliament, with those sorts of issues, and if everybody did that, then our politicians would get a better message across and realise that it is a major election issue, and that might cause them to change their way of thinking. we can on the political scene, we can also pressure our governments to provide additional funding for environmental protection and conservation. Here in Australia, I think the current federal government committed something like $250,000 $250 million to the protection of wildlife, or the protection of biodiversity, really, in Australia over a current term of government, which is for 3 years. So that might sound a lot, but it's not. I mean, it's really only a fraction of what's needed. And if we just look at the amount of money that we need to prevent existing threatened species from going extinct, we need to spend at least $3 billion a year. So when you have a government that's only spending $250 million over a 3-year period, you see how pitiful government investment in the biodiversity really is. So we really need to put pressure on the government to invest more money, and it's also the responsibility not just of government but of everybody to invest money in biodiversity. And one thing that people don't quite realize is that not only is our livelihood dependent upon the natural environment, as I said, but so is our economy. If those ecosystems collapse, so does our economy. And I'm tired of speaking to economists out there who see that there's no connection between the two. They think that that the economy is extralimital to the or an externality is the term that they use to the natural environment. And so that's why we really need to educate everybody that we are part of the natural environment, and every one of us can have a role in doing that. I mean, just having a conversation with your neighbour or your friend or a family member about those sorts of things can help change the flow of things, and it might take a bit of time, and we don't have that much time to do it, but everything helps. We can also create habitats for animals and plants in our towns and cities, and that starts with our own gardens. If we have a garden, simple things like putting hollow logs in your garden, or some rocks, or planting the locally native plant species in your garden, which are best suited for the conditions in your garden, also helps your local biodiversity. And urban areas, as I mentioned, can be very good for a broad range of biodiversity, and they can act as ways of producing surpluses of biodiversity that then can disperse to other locations. We can also go out into the natural environment a bit more, leave our towns and cities and have holidays in natural places, and interact with what happens naturally. And not only is it useful to other animals by getting to know what that biodiversity does, it's good for our mental health. And there's lots of studies now that are showing that if you go for a daily walk in green spaces, or if you go on holidays to those natural places and interact with the natural environment, it's improving your mental health. And that seems to be a growing issue these days. Poor mental health as our cities and towns grow in size, and as we become more disconnected with nature and become more pressured with everyday things. But going out into the natural environment is a release valve for all of those pressures, and
I think it makes you realize, it makes you realize more about the local wildlife when you have these activities. Like, I was on a trip in Greece some years ago, and this is when I discovered, the threat turtles face, for example, with beaches crowded by tourists and etc. And yeah, it was really eye-opening for me, and I wouldn't have gone there. I wouldn't really have thought about it. And all of a sudden you realize, you make the connection, with the environment and its wildlife.
Yeah, well, that's great. I mean, you're lucky that you're able to do that and make those connections. And everybody else who does exactly the same as you has exactly the same experiences. So it's just a matter of getting all of those people to experience those wonderful things. And it goes back to our earlier discussion about passion for the environment. And I did mention that one of the reasons I am so passionate about protecting the natural environment is that I've experienced it myself. And if everybody else had similar experiences, I'm sure that they would be just as passionate about protecting it as well.
Yeah, definitely. There was just one more example I wanted to cite because it was part of our project last year. I remember I watched a documentary about, it was in the US, taking place in the US. And it's about creating, kind of corridors for animals. And again, taking animals into account in our landscapes. And in the US, they have created these, or started to create these tunnels under motorways or roads so that animals can, go from one place to another across the road safely rather than being hit by cars and trucks. And they have seen really good results just by doing this, which I thought was really interesting. And obviously, I also have another example in mind from your region about the platypus. And I remember that's something we discussed with you. Because when you have constructions in a town, you don't forcefully take into account that the platypus moves. And if they don't have these corridors to move from one place to another, they are stuck, basically.
Yeah. Yeah, that's a really important concept. And going back to those roadways and those road corridors, wildlife kills on roads, particularly major roads, is a major issue worldwide. And America and Europe have really taken the lead on this, particularly America. And road tunnels is one thing, as you were saying, but the problem with any of those sort of types of crossings is that you actually have to direct the animals to those crossing areas or crossing points, and that creates an additional challenge in itself. Under road tunnels can also be problematic in that the dark spaces and because not much light is filtering down into those tunnels, and animals don't necessarily like going into those dark spaces because they're venturing into the unknown, if you like. There's been some modification of tunnels by creating a glass ceiling or a plexiglass ceiling on the road surface to allow road to filter into the tunnels underneath, and that does help the animals venture in a bit more readily. But probably the more successful type of road crossing are what are known as vegetated land bridges. So it's actually the traffic that's fed in through the tunnels underneath the bridge that's been vegetated on the top. So you might have these conical shaped tunnels or tunnel shaped tunnels for the traffic, and on top you've got soil and vegetation placed on top, and the vegetation grows and it creates a natural corridor for the animal to cross. And the only problem with those sorts of road crossings is that they take a while to create, and they're very expensive to create. And so you really are limited in the number that you can produce. But they are fantastic road crossings. And as you can imagine, a bird species or a mammal species or even a reptile is more likely to to move through vegetation above a road tunnel than they are to actually venture in underneath in a tunnel.
Yeah.
Yeah.
Yeah, that's interesting. So I just want to mention that this week I'm actually really excited because I'm going to release a podcast about an incredible restoration project happening in the south of England that involves the whole local community, whoever you are. You don't need to be forcefully an environmentalist to be part of it. And I think that's such a great example of what people can do. Because there are templates being created here and there around the world. I think it's important to also share this with people as an inspiration. So that podcast will go out before yours. And I'm sure I will share more examples in the future, but we do need to create this inspiration of what steps can people take. So there is still hope, and I wanted to finish on this question with you. What is your overall hope today for wildlife and a thriving future for animals?
Well, the overall hope is to try and reverse this biodiversity decline and to create a healthier environment. One thing that we haven't discussed at all today, but really should be brought up is we use a lot of pesticides, for instance, within our agricultural areas, and that does impact on the local environment broadly. I mean, one group of animals that we haven't discussed at all today, but are severely impacted by pesticides are insects, and it does appear from a range of studies that global insect populations have declined by about 1/3 over the last few decades, and since at least the 1970s, and it's been down largely to the use of pesticides. If we can start looking for more natural means of controlling pest problems rather than using pesticides, then that'd be really good, and it would certainly be a big boost to reversing the biodiversity decline. But that's certainly my main aim, to get people aware that we are in a major problem area at the moment. We need to change the way we do things, and more importantly, restore our natural environment back to health, normal health, good health.
Yeah. I'm glad you brought that.
A big challenge.
But pesticides, that's such a massive issue for wildlife. Then it goes into our rivers or oceans. All the consequences of it, our health. So this podcast is called Shades of Life, as every guest bring their own color, vision, and mission to it. So I always end the podcast with the same question for you. If you were a color, what would it be and why?
That's pretty easy. One of my other interests besides the natural environment is following English football, and the team that I've always supported, going back to my Liverpool days, isn't the Liverpool Football Club, but its rival Everton, and Everton's football strip is blue and white, and so I've always liked the colour blue. But it also has a connection with the natural environment because some of my favourite bird species are also bright blue. If you look at Australia's fairy wren species, particularly the splendid wren, they have vivid, or the males have a vivid blue plumage and really catch the eye. And a blue ocean also means that the ocean is a healthy one. And if you're lucky enough to travel along the southern coast of Australia in particular, you have some lovely blue ocean beaches. And that's largely as a result of the grains of sand that are in the water on the water bed, but and the way that the sunlight reflects off those grains of sand, creating that blue glow. But it's if the water isn't clean and clear, then that sunlight doesn't reach those grains of sand, and you don't get that blue coloration. So it's a sign of a healthy ocean, and I'm sure that there are other bright blue oceans in other parts of the planet as well. But I know those southern oceans pretty well.
Oh, that's amazing. Thank you, Stephen. So thank you for joining me on the podcast today. I really enjoyed having this conversation with you. I have to say that for me, you know, my own passion for the planet probably started with wildlife when I was a child. So that conversation meant a lot to me in particular. And I like that it links back, you know, to your own childhood with your teacher, Mr. Heron. I love the story. I'm sure you will inspire some young 9 years old today for this conversation for the future, I'm sure. Thank you for everything that you do, because as you mentioned, you are retired, but you are not retired. You are so active. And as you mentioned throughout on various occasions, education is so key, and you are such a big actor of doing this today as a voice for wildlife. So thank you again for joining me today.
Thank you very much, Ingrid. And look, it's been a pleasure to be here today. I might say that you know, I can only do so much, and I'm part of a much larger workforce of volunteers who are equally, if not more, passionate than I am. And you know, if we can get even more people on the same path, that'd be terrific. And I'm certainly trying to do my best to inspire a lot more younger people to follow the same path that I did too.
Amazing. Thank you very much, Stephen, and thank you to everyone for watching and listening.
Thank you, Ingrid.